All right, today we're going to be proving lines parallel. This is really similar to our last round of videos. We're just kind of doing the reverse of it. So it says, never assume that lines are parallel. You must use facts or theorems about relationships between angles. If you can show the set of angles are congruent or supplementary, then you can prove the lines are parallel. All right, so essentially we're using all those angles we learned, corresponding angles, alternate interior, alternate exterior, same side interior, to help us prove the lines are going to be parallel. So here's a picture here. We have our lines. We have A and B, and we have C going through, and that's that transversal. We have all 8 of those angles kind of happening here. So the first one says, converse of corresponding angles. All right, if 2 lines are cut by a transversal, so that the corresponding angles are congruent or equal, then the 2 lines are parallel. All right, so example from above, it says if angle 4 is congruent to blank. So if we have angle 4 right here, actually, here's angle 4. All right, looking for its corresponding angle. Remember, corresponding angles are on the same side of that transversal C. All right, they're on the left-hand side. One is interior and one is an exterior angle. So 4 is our interior angle. So that means that 8 would be our corresponding angle there. So angle 4 is congruent to angle 8 if the 2 lines are parallel. So you're looking for the figure out which lines are parallel. You look at that transversal C. What 2 lines is C going through? C is going through line A right there, and line B right there, so A is parallel to B. The next one, it says the converse of alternate exterior angles theorem. It says if 2 lines are cut by transversal so that the pair of alternate exterior angles are congruent, then their lines are parallel. So up here, we have angle 2. So here's angle 2. This one is the alternate exterior angles theorem. So alternate exterior angles are on different sides of that transversal C. So 2 is on the right-hand side. So you're looking for an exterior angle that's on the other side. All right. And that is not next to it. So angle 8 would be your answer. So angle 2 is congruent to angle 8. Converse of consecutive interior angles, or you can say same side, that's why I say the converse of same side interior angles theorem. It says consecutive interior angles are supplementary, then their lines are parallel. So it tells us angle 3 in this problem. So here's angle 3. You're looking for its same side interior angle. Same side interior angles are on the same side of that transversal, so they're both going to be on the right-hand side of C. All right, and since they're both interior angles, they're on the same side, they're next to each other, so angle 6. So if I have angle 3 and angle 6 there, they should add up to 180. So the measurement of angle 3 plus the measurement of angle 6 should equal 180. Next one, the converse of alternate interior angles theorem. If 2 lines are cut by transversal, so that the pair of alternate interior angles are congruent, then those 2 lines are parallel. And they give us angle 5 here. So look at this picture up here. We have angle 5, and we're looking for its alternate interior angle. Alternate interior angles are on different side of that transversal, so 5 is on the left, looking for one that's on the right, and it can't be right next to it, so it has to be angle 3. So if those 2 are congruent, then those lines are parallel. And the last one here, it says the converse of perpendicular lines transversal theorem. It says if 2 lines are perpendicular to the same line in a plane, then those lines are parallel. All right, so it kind of helps me if I draw a picture here. So it says if A is perpendicular to blank, and it has B and all that stuff. So I'm going to draw line A. So here's line A. It's perpendicular, we'll say it's going to be perpendicular to line C. Perpendicular lines that cut each other at a right angle. Okay. And we're going to say that B is perpendicular to C. So here's line C. You need to draw B so that it's perpendicular to C. So B would look something like this. So if that happens, you'll notice that A and B are parallel to each other then. All right, so here's where it actually helps us out. So It says if angle 2 and angle 3 are the same, so these measurements are the exact same, which lines are going to be parallel, and then state the postulate or theorem that explains it. So how I do these problems is I see what line are both angle 1 and angle 2 touching. All right, the angle 1 is touching line M and R. Angle 2 is touching line M and S. They're both touching line M here. So M is your transversal. Okay. It looks to me they are on the same side of that transversal. It looks like angle 1 is an exterior angle and angle 2 is an interior angle. So I'm thinking those are corresponding angles. All right, and to figure out which lines are parallel, what lines does M go through? Well, M goes through line R and line S. So I would say R is parallel to S, and my reason would be the converse of corresponding angles postulate. Example 2, find the measurement of angle ABC so that M is parallel to N. So we have these angles here. It gives us this angle right here, that's 6x minus 20, and this 3x plus 10. So we gotta figure out how those relate to each other. So to me, they look like they're both interior angles, so they're in between N and M. All right, they look like they're on different sides of that transversal, so I'm thinking those are alternate interior angles. And remember, alternate interior angles are equal, so I would set those equal to each other. So I have 3x plus 10 equals 6x minus 20, and let's solve for x here. I'm going to add 20 to both sides. And I'm going to subtract that 3x from both sides. And then divide by 3, and I get that x is 10. That's what they want. They want to find the measurement of angle ABC. So angle ABC is right there, so I need to plug that in. So 6 times x, which we just found was 10, minus 20. 6 times 10 is 60. 60 minus 20 is 40. So the measurement of angle ABC needs to be 40 degrees in order for those to be parallel. Awesome. And last thing, we're going to do one proof here. These are pretty quick proofs. It says angle 15 is congruent to angle 5. So I'm going to highlight those. Angle 15 right here is congruent to angle 5. My reason there's going to be given, because it's one of my givens. Okay. Now, if I have those going to be equal, they both lie on line M there. Okay. Which means the lines that M is going through are R and S. So that would prove that R is parallel to S. Our reason has to be one of our angles. If you look at 5 and 15, what types of angles are those? Well, to me, they look like they're on different sides of that transversal, so they're going to be alternate something. They both look like they're exterior angles because they're on the outside of those R and S. So I would say the converse of alternate exterior angles theorem. All right, the next one, change my colors here. The next one says 1 is congruent to 5. So angle 1 is congruent to angle 5. Now for me, those both look like they're on line R there. It looks like R is going through two lines. It's going through L and M. Oh, this is going to be given. So I'd say that L, all right, is parallel to M. We have to figure out why, what type of angles are 1 and 5. So 1 and 5 look like they're on the same side of that transversal there. So they're definitely going to be on the same side. Oh, it looks to me that 1 is an exterior angle and 5 is an interior angle. So I'm thinking those are corresponding angles. So I'd say the converse of corresponding angles